Explaining the mind map on table locks in my takes. 1. Overview. Table locks in MySQL are a synchronization mechanism designed to control access to an entire table during concurrent operations. They ensure data consistency and prevent conflicts when multiple users or processes interact with the same table. Table locks are particularly useful in non-transactional storage engines like MyISAM, which do not support row-level locking. Types of table locks. 2.1 Read lock, shared lock. Behavior. Allows multiple sessions to read data from the table simultaneously. Write operations are blocked, ensuring that no data is modified while a read lock is active. Use case. Ensures consistent reads when multiple users need access to the same table without interference from updates or inserts. Example scenario. Backing up a database while ensuring no ongoing changes corrupt the backup. 2.2 Write lock, exclusive lock. Behavior. Only the session holding the lock can modify or read the table. Blocks all other read and write operations until the lock is released. Use case. Prevents conflicts during operations that modify the table, such as bulk inserts, updates, or schema changes. Example scenario. Updating a table while ensuring no other process reads incomplete or inconsistent data. 3. When are table locks applied? 3.1 Automatic locks. Non-transactional engines, e.g. MyISAM, rely on table locks for all read and write operations. DDL operations, such as alter table, rename table, and drop table, automatically lock the table to prevent concurrent modifications. During backup processes, MySQL applies read locks, flush tables with read lock to ensure data consistency. 3.2 Manual locks. Developers can explicitly lock tables using lock tables. Examples: batch updates or migrations where synchronization is critical. Preventing conflicts in a multi-session environment. 4. Internals. Lock queue. When a session requests a lock and the table is already locked, the session is placed in a queue until the lock becomes available. Deadlock prevention. MySQL avoids deadlocks by granting locks sequentially, ensuring a session eventually proceeds. 5 Advantages. Simplicity. Easy to understand and implement, especially for simple workloads. Consistency. Prevents conflicts during critical operations like schema changes. Efficiency in low concurrency scenarios. Works well for databases with fewer concurrent users or sessions. 6 Disadvantages. Scalability issues. Blocking access to the entire table can create bottlenecks in high concurrency environments. Potential bottlenecks. Sessions waiting for the lock can slow down the overall system. Lack of granularity. Locks the entire table instead of specific rows, which may affect performance for large datasets. Best practices. Minimize locking time. Keep locked operations short to reduce contention. Use transactions for InnoDB. Prefer row-level locks in InnoDB for high concurrency scenarios. Avoid table locks for high concurrency. Use row-level locking instead of table locks to prevent system slowdowns. Optimized backups. Use tools like Percona Extra Backup, which do not require table locking. 8. Releasing table locks. Use the command unlock tables explicitly to release locks. Locks are automatically released when the session ends. Conclusion. Table locks in MySQL are essential for managing data consistency and preventing conflicts in non-transactional engines or during schema modifications. While they offer simplicity and reliability, they are not ideal for high concurrency